Good morning, everybody. I'm going to have a look at the important sections in Lesson 3. We're mostly going to deal with types and the operators, so formulas using the different types. Okay, in programming, we normally have the following types. And I gave you in the first column the types used in VB. The second column, the types used in C, another language. Just as an example, you'll see they are not really very different. So in VB, the one type is called an integer. The same sort of type in C is called an int. And this is now used to store whole numbers. So numbers without decimal positions. And normally that would be signed. Means it can go negative or positive. So examples would be the following few numbers: 50, 7,343, okay, as well as negative numbers. Now the same type in VB, integer, can also store real nice big numbers. But if I want to store something big, in C very often I will need to use a different data type, to store numbers that are bigger, either negative or positive again. Take note, the long type can also store small numbers as well. So in VB, I'm only going to use integer. In C, I will need to determine the size of the data that I'm going to store and then choose between int and long. You're going to learn the specific rules a little bit later on. The type double, so normally in VB it's a class, it starts with a capital letter. In C the type starts with lowercase characters, would be used to store a number that contains fractional positions, so decimal positions. And over here a few examples are shown, and again it can be a signed number. It can contain a negative or a positive number. We're also going to have a character. It's called char in VB, and exactly the same, it's only lowercase, char in C, and it's going to store one character for me, any character that you can think of. Over here, lowercase t, uppercase b, a hash, a 7, a p, any character that you can think of can be stored using the char data type. In VB we then have a type called string to store many characters, like a word or a sentence, or somebody's name and surname, or a company's name and surname. And see, it's a little bit more complex, so we're going to leave that one out for now. Okay, so all these different types uses different sizes in memory, and I'm going to pick the type that is important for my data. I would know what data must be stored. So if I need to store the number of students in a class, then I will pick integer, because I would normally have up to about 400 students maximum in a class, but I can easily go to 1,000 students as well. I will not pick double, because I'm not going to have 300.5 students in the class. As humans, we can't be divided into halves and quarters. That's not going to work. If I need to store the distance from one city to the next, then chances are that my data might have a decimal position, a fractional part, so I'd always go and choose a double for that. If I need to store one character, a code for a product, then I would choose a char data type. Okay, so the data that I store will tell me what data type to use. And the data types are a little bit the same between the different languages. The meaning is the same, It's the exact amount of storage space that they use would be different, and how or whatever their name specific might be would be different as well. If we now come back to our example, then in mathematics we simply specify some or another formula, and we don't care too much about the exact data, the result of that formula, whether it would be 1.333 or 1 on the dot. We don't mind too much because we don't need to reserve memory space for the result beforehand. In programming, we care because the result needs to be predetermined, the memory space that it uses, so the type of the data. And the type very often depends on the calculations, the different operators that we're going to use. And so my data type where the result is stored is dependent on calculations that I'm doing, as well as the operators that I'm using. If I now have a look at the following example. Let's say we've got num1, it's an integer, num2 a double, and result is a double as well. The first thing that you need to know is that if I multiply, add, or subtract different data types, then we can use rule of thumb, the biggest data type must be used for the result. So in this case, if I subtract an integer and a double, the double must be the data type of result. If I add an integer and a double, again the result will be of the type double. If I mix different data types, double is a bigger data type, it can store more data, and the result needs to be that. The same if I do multiplication. If I multiply an integer and a double, the result will be a double. So in this case, if I multiply 10 and 3.1, my result will be 31.0. The result will have a dot 0 decimal positions, but that's fine. I make provision for a number that might not be exactly a whole number. So 3.15 times by 10 will give me 31.5 in the result. At this stage, you're going to have an error in your calculations with your formula syntax. If you do something like this, you'd see a red squiggly line when you go to the real programming for VB or C or any other language that you're using. Okay, so do remember the result of my formula must always be for addition, subtraction, multiplication, the largest number that I've got. So I will need a double for result, not an integer in this case. Let's now have a look at division. And for this, I'm first of all going to call upon Wikipedia just to give us a little bit of information. So in algebra and science, I very often write a formula like this. A is divided by B. But in most programming languages, since we need to write the formula on one line, we will write it like this. A divided by B, the slash is my division operator. Let's have a look first of all at the different operators used in VB.NET. So for division, we've got really three that involves division: a forward slash, a backslash, and mod. I've included the operator to raise something to the power, just because I want to provide an example of that as well. Okay, so let's have a look at the forward slash. I'm going to use easy enough numbers. So if I've got 5 divided by 2, this will result in 2.5. If I've got something like 10 divided by 2, this will result in 5.0. So this first division operator results in a double result. Doesn't matter really what the operators would be on either side of the division operator. So if we've got something like 5.5 divided by 2, then 2.75 is the answer. If I've got a whole number or I've got a real result, every time my result will have decimal positions. Even if I've got a number that has no decimal positions, 5.0. So the type of this calculation, if I use the forward slash, would always be a double result. If I use the integer division operator, then my rule is as follows. I must have integer operators on either side of the division, so 5 divided by 2, and my result will be only an integer. So over here, both numbers must be integers, and the result is an integer. The decimal positions that I might have are truncated. We can say deleted, truncated. Okay, so that means if I've got something like 10 divided by 3, my result will be 3 again. If I've got, let's say, 13 divided by 3, the result will be 4 only. So every time I use the integer division, I get an integer result. We need to use this in specific circumstances. Sometimes we only want to use whole numbers, integers, in programming. If I need to calculate the number of eggs, if I need to calculate how many people, if I need to calculate anything that would result in an answer that I only have as a whole number, then I need this type of division. The modulus operator gives me the remainder of integer division. So if I've got something like 13 mod 3, the result will be 1. 13 divided by 3 is 4. How many numbers remains? 1. So 14 mod 3 will be 2. 15 mod 3 will be 0. 15 divided by 3 is 5 on the dot. Okay, so modulus we use for remainder in VB. I just want to cover raising to a power as well. In VB I can specify something to the power of a number. So 10 to the power of 2, like that. So 10 times 10. 10 multiplied by itself. If I want to specify 3 to the power of 2, so 3 times 3, it would be 9, like that. Now I can specify any number to any power that I need to. Just for fun, let's go have a look at division using a different language, C or Java. And here the rules are slightly different. So sometimes the rules differs per language. I'm going to use the division operator for integer as well as double division. And the rule is as follows. If either the numerator or denominator are of the type double, I've got division that will result in a double result. So if I've got 10.5 divided by 1, my result will be 10.5. If I've got 5.0 divided by 2, my result will be 2.5. If I've got 8 let's just say 8 divided by 2.0, the result will be 4.0. Let's say I've got 8.5 divided by 2, the result will be 4.25. So, if either the numerator or the denominator, if one of them would be a double, my result is a double calculation. I use the same operator for integer division, but now the rule is both numbers on either side of the division sign must be of type integer. That must be integer. And the type is actually, the precise type is called int, but we're talking, so integer is perfectly fine. So that means if I've got 5 divided by 2, both of them integers, the result is 2. If I've got 10 divided by 3, well, let's go for 10 divided by 4, then this result will also be 2. If I've got 8 divided by 5, the result will be 1. In primary school you learned about making groups. So if you've got 8 sweeties and you divide it evenly among 5 children, then each gets 1. We'll talk about the remainder just now. Okay, so the rule is the 8 and the 5, or the two numbers on either side of the division operator, if they are integer, then my result would be integer. I normally find that students make mistakes here quite often, because if you want to work out a percentage, 80 divided by 100 gives you 0, whereas 80 divided by 100, which is a double, will give you 0.8. Okay, so be careful for integer division that you get by accident. The modulus then, remainder operator in C and Java, is a percentage sign. So if I've got 10 divided by, let's say 4, the result will now be 2. 10 divided by 4, that's 2. What's the remainder? 2. So let's just use another example. Let's go for 5. Divide by 2, the remainder will be 1. And equal to now, if I've got 13 divided by 3, the remainder is 1. 14 divided by 3, the remainder will be 2. And 15 divided by 3, the remainder will be exactly 0. So, integer division, whenever I want the remainder of something that is an integer result, I'll have a look at an example in a moment. Okay, so let's have a look at an example where we need integer division and the remainder. We're not going to find this very often. It's only maybe 2% of the time when we need to write programs, we need to use integer division and the remainder operator. But here with an example. So let's say we need to do the planning for an event participation program. They say a person, so maybe the organizer of an event, needs to get the total number of participants for the event as well as the size per group that they want. So maybe they want to plan seating arrangements. The program needs to calculate and display the number of groups as well as the number of participants that doesn't fit into a group. So let's just work with an example. If I've got 100 participants and I need groups of 30, then I will have 3 groups, okay? And there would be 10 participants. That does not fit. Does not fit. Okay? If I've got 20 participants and I need, let's say, 7 groups, 7 members per group, then how many groups would I have? 7, 14, 21. So that means only 2 groups. And how many people does not fit? 6 people. Okay? Just to go through an example of this. So if I now need to go fill in my planning chart, input variables would be the number of participants. Total number of participants. Like that. If I now fill in the user interface control, for input we're going to use a text box always. The text box will have a txt prefix. I will use txt and then the name that I picked right at the start. Num participants. Exactly like that. I also need the group size. We go for nice descriptive names. And nice planning like that. And again, the input would be a text box because I use text boxes to get input in a GUI program. So txt group size. And you would notice that I'm filling this in Excel. You can either do it on paper, in Word or Excel. Excel, the whole purpose is just to make my calculations a little bit easier once I get to know Excel. So for this program, I don't think I will use any other variables. What output do they need? The number of groups, as well as the participants remaining. Let's go for long, nice descriptive names. Output, user interface control. I'm always going to use a label. So LBL and then the variable name num groups. For the participants remaining, I've got LBL participants remaining. And this looks like a rather long name, but in programming we'd rather be descriptive. So now if we go have a look at test data, and you can have at least 3 test data sets. When we get to selection, we're going to add a few more. So let's go with the first example that I gave. Let's maybe center everything like that. I want 100 participants, 30 per group. So that will give me 100 divided by 30. That's 3 for a whole number. And the number of participants that remains will be 10. So we can just calculate that. If you need to, you'll use your calculator. But if we stick with numbers, that's easy to calculate. No need. So the second example we've done as well. Let's say there's 20 participants, so we need groups of 7 each. So that means 4 groups, 14 participants are placed in groups, and 6 remains. And the last test data set, we can just pick values that would be easy to calculate. So let's go for 88 people. I need groups of 20 each. That would give me 20, 40, 60, 80. 4 groups, and I've got 8 participants. That isn't placed in a group. Okay? Test data like that. And just go for values that you can see where my picture isn't obscuring the data. So now if I go have a look at the planning, just going to delete that. I need the steps for the program, and in VB this would be my button. So it would have a prefix btn, calculate groups maybe, event procedure. So the access, step 1 is declare the variables. We do so. Step 2, we need to get the input. We know what input we've got. Total number of participants and the number of participants per group. So get the total number of participants and the size per group. Step 3 would be to calculate the number of groups, and here we're now going to use the variable names that we already selected. And I'm going to write down this formula on a new line. So my number of groups will be the number of participants divided by, we're ready for the VB planning, group size. So this gives me the number of groups. If you were writing your planning for a C or Java environment, this would be number of groups is equal to number of participants divided by group size, as I explained, because the rules for Java is different from those of VB. Step number 4, I need to calculate the remaining participants. So again for VB, this would be long name participants remaining is equal to the number of participants divide by and give me the remainder. Group size in a C or Java environment, it would be exactly the formula given, except we need to use the modulus operator for Java. Lastly, the last step would be to display the number of groups and the number of participants not placed in a group. Okay, so this example gives you an idea of when we're going to use integer division and the modulus operator. It's really about 2% of the time when we do programming. Normally we want division using a result that is a double. Lastly, I just want to mention the use of Excel. Excel is an application provided by Microsoft where we can do calculations with ease. So if I need to type a letter to my grandmom, I'm going to use Word. Word is developed for that purpose. But if I need to have a few calculations, Excel is a lot easier. The data is specified per cell that's got a column name, D in this instance, as well as a row name. So that means the length for test data 1 is saved at D1. The width for test data 1 is saved at D6. If I now need to go calculate any data, calculate the area. So area, I know, formula length times width. If I use the following, if I specify, take D5, so the data stored in D5, multiply that with the data stored in D6. So again, I just specify my formula. I start with an equal to sign, and I've got the result. If I now need to go calculate the perimeter, I can specify, take the data in D5, multiply that by 2. I can use parentheses if I want to. Take the data in D6, multiply that by 2, by 2, and add those two results together. Let's just use parentheses for both of them. No huge need. But if I go calculate that, it calculates my data. If my second and third test cases are now entered, I can simply take this, copy, and paste the formula. And again, paste the formula. And I don't need to work with the formulas again. So if I copy this formula, I can paste it and paste it again. And this is the real use of Excel. So let's say now my field is not 4 meters long anymore, it's 6 meters. My formulas, the moment that I update this data, the area as well as the perimeter were updated as well. So if my length was 4.5, works out my area as well as my perimeter like that. You do not need to use Excel. Excel is just a terrific tool for programmers to use. Thank you.